Hello everyone and welcome to the Dragon Code. In this video we are going to look at function prototype and recursion or recursive functions. So let's start. Let's declare and define some function. It will have void type. I will name it hello. Let's define it. It will print hello world. And now I'm going to call it. And now when I run this code, everything works fine. Hello world is printed. But if I declare and define this function here after main function, it won't work. This is because program in C++ go line by line. So there is no hello function before this line. But there is a way to define function after main function. For that, you need to use function prototype. It is actually function declaration and then after you define that function. So I will just declare hello function here and I will define it later. And now when I run this code, it works. Let's declare another function with parameters. It has two parameters. This is function prototype. And here I'm going to define this function. And I'm going to print return value of that function here. First I'm going to call it. I will add parameters. And it works. So this is basically how function prototype works. Let's move now on recursion or recursive functions. Recursive functions means function that calls itself. Before moving on recursive functions, you should know that you can call user-defined function inside another function other than main, and how it works. Let's do that. Here I'm going to define function parent, and it will print parent start and parent end. I will also declare another function child function. And here I will also print child start and child end. Here I'm going to call child function. And it won't work because the child function is declared after parent function. So I need to move it here before parent function. And here I will print in main function main start and main end. And I will call here parent function. Let's remove those empty rows. And now I'm going to add one tab to text inside parent function and two tabs inside child function to make it more clearer. And let's now run this code and see what will happen. This is output of this code, so program starts in main function. This line of code is printed, so main start, and then we called parent function. So from here we move to parent function, and only when parent function is finished, then main function can continue its execution. So here first main function start, and then we move to the parent function. In parent function start, and then it moves to the child function. And here child start and child's end. And only when child's end we can now move to the parent function again. So parent function end, and when parent function is finished, now we can return back to the main function and execute all the remaining lines of code. So that was the flow of this program. As you can see, main function starts and waits to parent function, and then parent function also waits child function. So in this situation we having two functions waiting each other to finish. And now when child is finished, parent can continue, and when parent finished, main can continue. This is important to know before moving on recursion functions. Let's now finally move on recursion. Recursive function is function, as I said before, that calls itself, and it also acts like a loop. You need to specify condition where it will stop calling itself, otherwise it will never end and it will call itself forever. Okay, let's now declare some recursive function. I will declare recursive function that adds all number in a certain range. I will call it sum all, and it will have one input parameter r. So I will first define condition where it will stop looping, and it will be when r is 0. In that case, the function will return 0. And in case it is not, it will return r plus, and then here I will call this function all with r minus 1. I didn't put here else, but I could also add if else statements. It is same, because if this line of code is not true, it will be avoided and it will move here. And if this line of code is true, it will stop here. It will return 0 and it won't move here. And let's now call these functions. I will pass 2 as parameter, and then I will pass 3, and I could pass 6. And let's now print this code. So when input parameter is 2, when I pass 2, result is 3. When I pass 3 is 6. When 6 is 21. Let's go step by step for what actually happened here. So I will do it when we pass 2 as input parameter. So we call function sum all and pass value of 2. So first we check if r is 0, it's not, so we move here. 2 plus, we again call this function sum all, and here we pass value 1. And now we wait to this function to finish. Now this function here waits this function, just like parent was waiting child. So now this function is going to be executed, sum all 1, and here you first we check is r 0, it's not, so we move here, r is 1 plus sum all of 0. And now we also need this function to finish, to move and continue to executing this function. So this function also waits. It is like in previous example when main waits for parent and parent waits for child. So I also move here. It is sum all of 0. And here we check is r 0. It is. So return 0. Now this function, when 0 is passed, is finished. It returns 0. This is what we were waiting to this function. So now we can continue finishing this function when input parameter is 1. So it is 1 plus result from this function, and it is 0. And it is equal to 1. So we will return 1. And now we also have return value of this function where input parameter is 1. Now we can move to this function where input parameter is 2. So it is 2 plus result from this function, and it is 1. It is 1, and this is equal to 3. So we will return 3. Let's also do it when input parameter is 3. So first we call this function. And this function starts executing. R is not 0, so we will executing this line of code here. R 3 plus sum all r minus 1, which is 2. Now we wait for this function to return value, so we move in executing this function. Now in this function we go the same process. R is not 0, so we move to this line of code. It is 2 plus sum all r minus 1. It is 1. Now we need this. Now this function waits result from this function. So we move executing this function. r is not 0, so we will execute again this line of code. 1 plus sum all of 0. And now this function waits this function to return value. So we are now moved to execute this function. Sum all of 0. It is r in this case is 0, so it will return 0. And now we have return value of this function. So we move in here in this function sum all when input parameter is 1. So it is 1 plus result from this function, it is 0. And it is 1, so we will return 1 from function where input parameter is 1. Then we move to sum all function because we have result from sum all function where input parameter is 1. We have result here, so we can move here. So it is 2 plus return from this function, it is 1. It is 3, and we will return 3. Now we have result from this function. So we can move to this function when input parameter is 3. So let's do that. It's 3 plus result from this function. It is 3. It is 6. So it will return 6. And let's run this program. As you can see, when 2 it is 3, and when 3 it is 6, and so on. This is all for this video. If you like this video and want more videos like this, press like button and subscribe, and see you next time.